Hi guys, big big welcome back to this video series. And so for today, what we are going to do is that we are going to talk about the follow-up from the previous chapter, chapter 11, about logic gates. Now, in the previous chapter, it was very simple. You either use an AND gate, OR gate, NAND gate, so on and so forth. But a lot of times we have to use a combination of the different gates in order to make a solution for a problem that we face. So this is where I will teach you how to combine different gates in order to come up with a solution to a problem. Okay, so a couple of things. First part is, of course, how we are going to describe a combinational logic circuit. Okay, so this is the thing. So right now, if we are looking at this circuit here, what we have is a NOR gate. Sorry, what we have is an OR gate and an AND gate. So this is a combined logic signal, right? We have two different kinds of gates. So we want to find out what is the output X here. Yeah, we want to find out what is the output X. So what we need to do is we need to kind of come up with the intermediate signal here before we can come up with X. Yeah, so we want to take it one gate at a time. So when we draw a truth table, it's going to look slightly different. So in this case, we still have three inputs, A, B, C. I'm not going to be too concerned about the whole situation and the parameters here. I just want to teach you how to derive the output X, okay, eventually. So I told you that three inputs A, B, C. I would want to derive the intermediate signal, and let's call this D first. So D is A or B. Okay, D is A or B. So I'm going to have an additional column here called D, A or B. So I'm just going to look at A and B here. So I want to find out which gives the truth table for an OR, right? So OR 0, 0 is a 0, 0, 0 is a 0, 0, 1 is a 1, 0, 1 is a 1, 1, 0 is a 1, 1, 0 is a 1, 1, 1. Okay, so this is the signal for D. This is the intermediate signal. And now we can go on to the output signal X. Because X is D and C. All right, so I'm looking at X equals to D and C. So it's a good idea to come up with a separate column for the intermediate signals and write down what the intermediate signal is. In this case, D is A or B, X is D and C. So we are looking at C and D, okay, N. So remember, N, 0, 0 is a 0, 1, 0 is a 0, 0, 1 is a 0, 1, 1 is a 1, 0, 1, 0, 1, 1 is a 1, 0, 1 is a 0, and 1, 1 is a 1. So now we have come up with the truth table for the output here. Okay, so this is the truth table for the output here. Now, what I want to do is to come up with something called a sum of product expression. So I want to find out if, let's say, I were to tell you, okay, come up with a equation and an expression that relates the ABC to the output X. Yeah, so I can tell you that X would be true. That means 1. X would be true here in three situations. X would be true. Let's use a green. X would be true. This don't seem to be working. So I'm going to use a different color. Let's go with blue. X would be true in three situations. Yeah. So X will be true in three situations. So X will be true if this happens, or this happens, or this happens, right? There are three situations, three scenarios whereby X becomes true. This, or this, or this. So X is true. X is true if A complement and B and C happens, right? If A is 0, B is 1, C is 1, so X will be true if this happens, or or A is B complement and C complement happens, right? A and B complement and C happens. Or there's another situation whereby X is true. Or, so this is the or, A happens and B happens and C happens. Okay, so this is what you call SOP, sum of product expression. So this will tell me, this expression tells me X will be true, X will be true if A complement and B and C occurs, it will be true, or A, B complement and C occurs, or A and B and C occurs. So in this case, you're telling your customer, you're telling other people reading your solution that the output will be high, a true, a 1, a 5 volt if these three scenarios will happen, or either of these three scenarios will happen. Okay, so this is essentially what I would need you to do. These few pages kind of illustrate what I told you. So yeah, so now looking at this other scenario here, okay, looking at this other scenario here is to train you to come up with the SOP expression, the sum of product expression. So if I gave you this table, would you be able to write out the SOP expression? Give it a try, follow the steps that I did, and hopefully you'll be able to come up with the solution here. Okay, SOP. This is another work example. I want you to try this work example out. Okay, come up with the SOP. And right now, what I'm going to do is that I want to go through with you maybe this example here. Okay, I want to go through with you maybe this example here. And to start right from the beginning to come up with the intermediate uh, signals, and then eventually come up with the SOP expression for the output Z. Okay, so let's draw our truth table first. So we've got three inputs. So what we need is, what are the three inputs? D, E, F. So let's draw a D, E, F. And remember, with three inputs, you need a 0, 0, 0, 0, 1, 1, 1, 1. 0, 0, 1, 1, 0, 0, 1, 1. I'm going to draw some lines to help guide. Okay, so it'll be neater. All right. Tell you what, let me pause the video here and then let me finish drawing the lines first. Yeah. Okay, so yeah, excuse the untidy table. When you draw this, please use a ruler and a pencil. Okay, so I set up the table. Remember, it has to be in 4 zeros, 4 ones, 2021, 2021, 010101. Okay, it must be in this format. And then I've written the intermediate signals. G is not of D, H is E and F, and Z, the output, is the NOR of G and H signals. Okay, so let's do the G intermediate signal first. G is very simple, it's just the opposite of D. So let's look at D, and we are going to write the opposite. So it's 0, 0, 0, 0, and now the opposite is 1, 1, 1, 1. 4 ones, the opposite of the 4 ones is 4 zeros. Okay, done. H is E and F. So I'm looking at E and F. 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1. Okay? So it follows the same pattern because it is a AND gate. So now the output is G NOR H. Okay, it's a NOR gate. So it must be a NOR. Okay, not an OR. So this is OR. Ordinarily it will be 1, but it is not an OR. It is not an OR. It is not an OR. Okay, so this one is also not an OR. Okay, this one is supposed to be a 0, but now because it's not an OR, it is a 1. Same thing, not and or is supposed to be or is supposed to be 0, but it's not and or, so it's a 1. It is not an or, so it's a 1. And this one, ordinarily or would be a 1, but since it's not an or, it is 0. I hope I didn't confuse you with that. Go and check out the NOR gate truth table if you're unsure of this. Okay, so right now, we have finished coming up with the truth table, and we can come up with the SOP. We can come up with the SOP um, expression for this. All right. Uh, let's see. Let's use a different color, maybe green. Let's go with green. So I know Z will be true, right, in these three situations. So Z will be true if this happens, or this happens, or this happens. Okay, so let's write that down. Z is true if D and E complement and F complement happen. So D and E complement and F complement happens, or the second scenario, D and E complement and F happens, or there's one more scenario that Z will be true. So I'm just gonna write here, I don't have space. D and E and F complement happens. Okay, so this is the SOP expression for this logic circuit. All right, so you must be able to, by the end of this video, be able to come up with the truth table, draw the truth table, fill in the truth table, and using the truth table, come up with the SOP expression. Okay, so go and practice for this one, and I will see you in the next chapter. All right, oh sorry, the next video on this second part. Okay, so go practice, and then I'll see you in a bit.